Hello, I'm Michael Valeri, and welcome to the Valeri Analytics channel. This is class number 2 of our SQL Immersive series. It is a code-along, and today's class we're going to be covering filtering data with the where clause and aggregating data in SQL. Before we get started, let's open up the Valeri Analytics YouTube SQL Immersive Curriculum folder, which is a Google Drive link below. And we're going to open up class number 2, where and aggregates. I will double click that document and I'm just going to copy and paste all of this right into the Mode Analytics terminal. Now today's class is all about filtering and aggregating data. And filtering data is something that we do all the time when we're using a tool like Excel. For example, I could have my albums table here, and let's say I only want to look at the rows that are rock. That is an example of filtering. Maybe I only want to look at the rows that are rock that have a rating maybe greater than 4 or 3. Well, I guess they all do. So filtering data is concerned with the rows or the records of the table. What did we learn in our last class? Well, we learned the select statement. The select statement selects columns of data, the columns that you want to see. From talks to the table that you want to talk to. Order by orders the results or the rows and records in the table from A to Z or Z to A, and limits the amount of records. We're concerned with the where clause, filtering on the rows of the raw table. Select statement is the columns, the where clause is the rows. It's the the horizontal nature of the table. So let's jump into mode here. And there's going to be two themes when filtering data. One is case sensitivity starts to matter when you filter data, and data types become important. So the two things to keep in mind in this filtering class are, and I'll just say them again, case sensitivity and data types. They're going to influence the way that we write our code. Those are the two themes with the where clause. And I would argue that the where clause is one of the more complicated SQL keywords because it is so finicky. I like to consider it a picky dinner guest. But filtering is important, so we need to learn how to do it. Let's start with our first question. One condition, one column. And as we work through these examples, the filtering is going to get more and more complicated over time. So the first one says, I just want to see a list of rock albums. A great thing to do before you actually start filtering data is looking at the table itself. So writing a separate query that just looks at the rows of the table. So let's pull up mvaleri 12 albums. And let's just find what column is going to tell us if a CD is rock or not. It would appear that it is the genre column. So here in the where clause, now that we have our table in front of us and we can see what ingredients we're going to use, we know that we're going to be filtering on the genre column. And where clause statements are always conditional. You're always equaling something, greater than something, less than something. They're all commands. So let's say where the records in the genre column are equal to single quote, rock, and single quote. You might be wondering, hey, Michael, why did you put single quotes around the word rock? Well, if you're working with a text or date column, text or date, you are going to wrap your filters in these single quotes. If you're working with, let's say, a Boolean or a number, you don't need to use single quotes. This is where data types matter. So what do we know about the genre column? It is indeed, let me just bring it up here on the side, Embolary 12 albums. The genre column is a string column, text column. So we wrap it in single quotes. So let's run this. And you'll notice that I wrote rock in an uppercase R because that's how it appears in the table. But we notice when we run this query, the result output, we get a list of the rock albums, but do we know that they're rock? Remember in last class about the order by? Just because we order by something doesn't mean we selected it. Just because we filtered on something doesn't mean we've selected it either. So if we want to see that column, we're just going to do comma genre and bring that to the forefront so we can actually see that if what we filtered on is appropriately displaying, and indeed it is. Let's move on to something, another example, one condition, one column of data. It says, I want to see a list of albums with over 1,000 plays. Okay. So, what column do we want to filter on in this case? We want to see a list of albums with over 1,000 plays. I think we want to talk to the plays column. And just for the sake of it, let's just do a select star from Embolary 12.albums so we have the table in front of us. I always find that this is really helpful just to have the table in front of us while we're writing our filter. So we're talking to the plays column, and we want to know albums with over 1,000 plays. So we're going to say where plays are greater than 1,000. Since the plays column is it's considered a float here now. Very, very interesting. I remember in my last class, it wasn't showing up as a float, but now these are these are with decimals. Plays over 1,000, we don't need to wrap it in single quotes because it's a number. So let's run it. Happy Thoughts has over 1,000 plays. How come we don't know how many plays it has? Is because we didn't select it. So let's bring it into the select statement and run it again. Similarly, this is for 1,000 plays. But what if I commented this out, and just to show you how fluid you can make these filters, we could say where plays are greater than or equal to 1,000 as well. Would that give us a different result? What the hell does that mean? Let's try that. Okay. Summer Mix, 808s and Heartbreaks. Okay, so we have more. So we can use this greater than or equal to as well. And similarly, you can use a lot of different commands here. You can use greater than or equal to, less than or equal to, greater than, less than. There's doesn't equal. That one's really powerful, where two alligators arguing with each other. So play around with all of these different types, and then there's obviously equals that you can use as well. You can use these for numbers. You can use these for dates. Let's move on to another example. So we have a date example. I want to see a list of albums released in 2011. What are we going to do? Well, before we query, we're going to select star from Embolary 12.albums just to have the table in front of us so we can see what that table looks like when we're filtering. So let's go over to the release date column. And what do we see? The release date is written in an interesting format. The release date is written in this kind of YYY, MM, DD, hour, minute, second format, which means when we're filtering on a date column, we need to follow this formatting for dates. Because we know that the release date column is a date. No, it's kind of hard to see here because they have this. Hey, mode, you guys got to get rid of this little chat icon because it's over the schema and it's really hard to see what the things are, but it's a date time format. All right, so if the album's released in 2011, we're going to say where release date, and I'm going to teach you about between. We're going to say where the release date is between 2011 0101. Notice we're following the year, month, day. We don't need to put the hours, minutes, and seconds necessarily because we're only concerned with the date itself, not the hours or the minutes or the seconds. So where the release date is between this and what is the final date of 2011? Well, it's 12/31. So some notes about the between function. Between is inclusive. It's going to include the beginning range and the end range in your result output. And it's very useful. So let's run the code to see the list of albums that are released in 2011. What do we have here? We have The Carter 4, New Kids on the Block, Happy Thoughts, I'm With You, all released in 2011. However, how come we don't know the actual release date? It's because we didn't select it. So let's select it as well. There we go. Now we have the actual dates. Now, there's an easier way to filter on 2011. In fact, there's an easier way to filter on dates. You can actually truncate dates just to the year, the month, the day, the year and the month, just the day. Dates can be manipulated in many different ways. So let's learn a new command, which is toChar. What toChar does is it will allow us to truncate a date. So what is one of the ingredients in toChar? Well, it's the column itself. We're saying, hey, can you manipulate the release date? And when you manipulate that release date, can you extract just the year? So you notice I'm putting these single quotes around Y. That's because we're creating a date or a text column as a result output of this. So that's why I'm wrapping them in these single quotes, is indicating that the result output of this function is going to be a string or a date-like column. So I'm going to say where the release date, can you extract the year out of that? And then what kind of column do we want to call this? Well, let's say as release year. Let's run it and see what happens. Would you look at that? We've truncated the release date column to release year. We've just pulled out the year. You can get really fancy with this, in fact, and we could just pull out the month. And we might want to call that release month. And maybe we want one called release month year, where we extract the year, and the month out of there as well. Let's try that. Nice. If you're somebody who likes things that are orderly, you're going to love the toChar command. It's awesome for truncating dates. It's a really great way to just strip out exactly what you want out of a column of data. You might be asking yourself, Michael, how do you know all these little commands like YYYMM, YYYMMM? Well, let's hop over to the teacher guide. If you go down to page 5, part 1, common functions operators, I've actually listed the functions from the last class, which is distinct, cast, and then now toChar. So here you have this nice little glossary index. And if you want a more extensive list of how you truncate dates, you can actually truncate them in more ways than just this. I'm going to go to the Postgres documentation just to show you. And in fact, you have a pretty wide array of ways that you can truncate a date. Let's try dy, which is going to give us the lowercase day name. So I'll hop back here into mode. Let's try that one. So I'm going to say 2car again. We're going to look at the release date column. And then we're just going to pull out dy as release day of week. This is going to give me the release day of week. Look how versatile this function is. I love it. It's so powerful. Sometimes when it takes a while like that, I just like to cancel it, but okay, it looked like it ran. Okay, great. Thursday, Friday, Monday, Monday. That's awesome. Can you imagine? You just want to know all the releases on a particular day of week. I think the most common is Tuesday or Thursday, based on what I've heard in the past. Those are release dates for albums generally. All right, so how do we simplify the filtering here? This is cool. This question said, I want to see a list of albums released in 2011. What do we know? Well, we were able to create just a column called release year. This would be great if we could leverage the 2car command in our filter. We could actually filter on the column that we created. So let's try that. I'm just going to comment out this where clause, and I'm going to write a brand new one where we're going to say where the release year column is equal to single quote 2011 because we're interacting with a date column, so we want to still wrap those in single quotes. So let's try this and see if we get anything. Okay, this guy comes up and he's really sad. It says, looks like there's something wrong. Column release year doesn't exist. What do you mean it doesn't exist? I wrote it. It's right here. The release year column is right here. I'm going to let you folks in on a little secret. I hinted on it in the class before. Is that the order in which SQL is written does not actually match the order in which it's executed. So let's go back to the 4-week SQL Immersive guide, and let's just look at the keyword chart. What do we notice about SQL? What's the first thing that runs? From. The from command runs first. However, it's listed second in the written execution, or the written sequence, but it actually happens first. So we look at the table, and then what happens? Well, after we look at the table, then we filter on the rows that we want to see. Step 2, the where clause happens before the select statement runs. Therefore, you cannot use columns that you created in the select statement in the where clause because they haven't been created yet. This is a big revelation. This is something in SQL I did not know until years later. I was like, why can't I use my aliases? Why can't I use the columns I've created in my where clause? It's because they haven't been made yet. The where clause runs after the from statement, and then select runs after that. So we're kind of caught in a conundrum here. We cannot use aliases in the where clause. And I'll even make a note of that. Cannot use aliases in the where clause. What a bummer. Can't use aliases in the where clause. So then what do we do? Well, we don't have to use the alias per se, release here. Why don't we just use the whole function itself? Because doesn't release date exist? So instead of writing release year here, let's just paste the whole function here because that represents release year inherently. And we know the release date column already exists after we talk to from because it's already baked into the table. Now let's try to run it. Now our result output works. So, to reiterate, you cannot use aliases in the where clause, but you can use the functions that created them in the where clause to get around that. And that's a little hack. A lot of content there to sink your teeth into. All right, let's move on to another date example. I want to see a list of albums released on a Tuesday. How do we get a list of albums and the day that they were released? Well, what did we learn? We learned 2car in the last example. So let's bring in the 2car release date dy as release day of week. Let's throw it down here. And I'm actually just going to run this as is now, just to see a list of albums in the release day of week. So if we want the ones released on a Tuesday, can't we just say where the release day of week equals, looks like it's written TUE, lowercase. We wrap in single quotes because it's a date. Let's try to run it. Oh, we get an error. Release day of week doesn't work. Why does it not work? It's because release day of week is an alias. It's not in the MValary 12 albums table. We're creating it. And what do we know? Aliases don't belong in the where clause. Instead, we're just going to copy the whole function itself and get around that alias issue. Now let's try to run it. Bada bing, bada boom. We get the answer. Powerful. All right, let's move on to the next question. Now we're going to introduce more than one condition into our where clause because you can filter on more than one thing. It says, I want to see a list of rock and rap albums. Okay, you want to see a list of rock and rap albums. We know that the column is called genre, right, from our last example. So we know we're going to be talking to the genre column. This is a text data type. So let's just start with the first one. We want to see where album equals rock. And genre equals rap. All right, that's how it's listed in the question. What do we know? When we filter on something, we might want to bring it into the select statement so we can see it, make sure it's working. Doesn't look like the query returned any results. Why do you folks think that is? Well, think of the word and. Let's think of this for a moment. I want to see an album that's rock and rap. An album can only be one or the other. It can only be rock, or it could only be rap, or it could only be something else. It can't be both at the same time. So instead of saying and, let's say or. So when we're filtering on multiple conditions, use and or. Look at that. Now we've got the rock and the rap albums in the same list. As I said in SQL, there's always more than one way to filter on something. So let's remove that, and I'll show you another shortcut. Let's say where genre in. In allows us to filter on multiple conditions in the same column. For example, we want to look at rock or rap albums. Rock or rap albums. What column are those featured in? The genre column. So if you've got more than one condition in the same column, you can use in. So in allows us to search for an array of values within a column. And the syntax is going to remain the same. Since we're filtering on a text data type, we're going to write rock with the single quotes around it and rap with the single quotes around it. Multiple conditions in the same column, separated by a comma. That reduces the redundancy and can be really powerful. Let's say you wanted to bring in pop albums, you just put a comma and write pop, etc., etc. I really like in. I use it all the time. Sometimes it takes a while for this to run. Okay, rock and rap, pop. There we go. Nice. So filtering on multiple conditions and or, but if you find out that those conditions are in the same column, you can use in instead and create an array of values to search for. Let's move on to the next one. This one's kind of hard to read, so I'm just going to put it on another line. It says, I want to see a list of rock and rap albums with at least a rating of 4. Multiple conditions again. Okay, let's start here. We probably want to say where the genre equals, or excuse me, we want rock and rap still. So the genre in, multiple conditions, same column. Rock and rap can be found in the genre column, so let's use in. Where the genre is rock and rap, and the rating is at least a 4. So they must be rock and rap, and let's have the rating be greater than or equal to 4. Why aren't we wrapping 4 in single quotes? Because rating, kind of hard to see here, it's down here in the corner, is a float. It's a number data type. We don't need to wrap it in single quotes. Let's highlight it and run it. Here are the albums that are rock or rap, and the rating is greater than or equal to 4. How come we can't see their genre rating? We haven't selected it. Let's bring what we're selecting, our filtering on, into the select statement so we can see that this is making sense. So here's the where clause here. Those look good. You might be noticing something about the where clause now. I want to point this out. The select statement separates columns with commas. Where statement separates columns with and or ors. It's a common issue that I see when people are learning SQL is when they get down to the where clause, they want to start putting commas next to every column that they're entering. These where statements are just conditional statements. They read like English in a lot of ways. So just be aware of that. The select statement, you separate columns with commas, but in the where statement, you separate columns with and or because you're looking at conditions. Let's move down to the next question, null conditions. I want to see a list of albums with no artist name. Okay. So I want to look at all the albums with no artist name. Let's just pull album and artist from here as is. So we want all the ones where it's blank, it's missing. Okay, so the artist column is a string. So let's say where artist equals null. Remember null, blanks. Let's try that. Didn't give us any results. Why is that? Well, do you think there's a band out there named Null? There could be. There could be a band named Null. So we can't search for the string null. In fact, when we're looking for nulls, we can't use equals. When searching for null values, we use is. So we're going to be using the is command. We're going to say where artist is null, is blank. Isn't this interesting how SQL is so picky in the where clause with all of these different operators and commands? But it's in the Immersive Guide glossary. I have it in here if you need to reference it. The basic operators, what in does, the definition, between, is, how they interact with different data types. So when searching for nulls, we use is. Inversely, you can actually invert your filtering too by saying not. So you can say where artist is not null. This could be really helpful if you're looking through an orders table and you want to see all of the orders where there is a customer name and maybe the orders where there's not a customer name, because it could indicate that there's an issue or error with the data and you need to quantify it. That's why it's important to look for nulls, is because it can help us quantify errors in our data where things are missing. So inverting it, you can do is not null as well. Okay, let's move on to, I want to see a list of rock albums with at least a rating of 4 or the album was burned. Okay. So I want to see a list of rock albums with at least a rating of 4 or the album was burned. Ooh, this one's more complicated. Well, let's just start here. Let's just write this function as is and see if it's giving us what we want it. So I want to see a list of rock albums. So where the genre equals rock. And the rating is at least 4. Okay. Or the album was burned. So the burned needs to equal. Burned is a Boolean. Genre is a text data type, so it gets wrapped in single quotes. Rating is a number, so it doesn't get wrapped in single quotes. But what about Booleans? Booleans don't get wrapped in single quotes either. You're just going to write true or false. So where burned equals true. What do we know? Because we're filtering on something means that we should select it so we can see what the columns are, the values. We need to bring them to the forefront. Then I'll run selected. And what do we have here? We've got the list of the albums. We got their genre. And we've got their rating. And we've got if they're burned or not. Okay, let's just walk through the list and see if this makes sense. It says I want to see a list of rock albums with a rating of at least 4 or the album was burned. Let's look at the first record. Okay, is this album rock? No, it's not. Then why is it here? Is its rating at least 4? Well, it's actually 5. But it's burned. Actually, in fact, we have a ton of albums here that are not rock. They're actually rap, pop, and comedy. Why is that? Well, it's because of the OR clause. There's actually 2 lists of data being generated here. When you throw in an OR, when you start an OR clause, you generate a new list of data. A lot of people don't know this about the OR clause. So here we have a list of data. This is actually list 1. And then we have list 2. We've got a list of rock albums that are greater than or equal to 4. Do you notice all these rock albums are greater than or equal to 4? Or we have a list of burned albums. There is 2 different types of data appearing in this result output because of OR. So when you start an OR clause, you're going to generate a new list of data. OR disregards everything that was written before and starts a new search query. So let's say we wanted rock albums that met the rating condition or the burn condition, but they still must be rock. Still must be rock. Must be rock. We could say instead, well, hey, can you create a list of rock albums where their rating is greater than or equal to 4? Where their rating is greater than or equal to 4? Or can you generate a list of rock albums that are burned? What are we going to get here? We're going to get list 1. Rock and rating over 4. And we're going to get list 2. Rock and rating, rock and burned. So we're going to get a list of rock albums that meet one of the 2 conditions. We're just separating into 2 different lists. Let's comment this out. And let's run this. Let's see if we get the list of rock albums that meet one or the other condition. Let's start with Bang Camaro and ask ourselves, is it a list 1 or a list 2 item? Bang Camaro, is it rock? Indeed it is. Is its rating greater than or equal to 4? Doesn't look like it, but is it burned? Indeed. The Bang Camaro record is being returned because it's part of list 2. Let's look at the second one. freaked out and small. Is it rock? Indeed. Is its rating greater than or equal to 4? It is. It's not burned. The reason this is being returned is because it's part of list 1. Let's go to the I'm with you example. It's rock. Its rating is greater than or equal to 4. And it's burned. It's actually part of list 1 and 2. Is the reason it's being included. However, SQL's not going to show it twice because it's part of list 1 or list 2. It's going to say, hey, you're part of this list already. Well, then you don't need to be included in the other. We don't need to repeat that value over and over again. So when you're creating your different lists using OR, it won't do duplicates, which is really powerful. I'm going to show you another way to write this. Do you see how complicated this question could be? So depending on what your business partner asks you, will determine how this is written. You'll notice here in this example that we write rock over and over again. It's redundant. We write it twice. So what if we could do this instead? What if we could say, where the genre equals rock, and parentheses, and where the rating is greater than or equal to 4, or burned equals true. No, I really got to pull this down here. What do we know about SQL? That it runs from the inside out. Our functions run from the inside out, and the same thing with the where clause. So what's going to happen first here is that the rating greater than or equal to 4 or burned equals true, that list is going to be created first, or those conditions are going to be run first because they're written in parentheses. So we're going to say, give me a list of albums that are greater than or equal to 4, or give me a list of burned albums. So you're going to have a list of albums that are greater than or equal to 4, or a list of burned albums, all in the same list. Then what's going to happen next is we're going to go outside of the parentheses, and now they have to be rock. So we start with rating greater than or equal to 4, or a list of burned albums that are all in the same list. And then we see if those are rock at the end. This is what we call contained OR. Contained OR. OR runs first with parentheses. So you can create all kinds of different ways of filtering using these parentheses. If you want your filtering to start first with these kind of filters and then with these kind of filters later, you can use parentheses. What's the takeaway here? The OR clause generates a new list of data. It disregards everything you wrote before it and starts a new list. Just be aware, OR can run amok in your code. All right, let's move on to the last filtering question. It's called pattern matching. It says, I want to see a list of albums that have a the in their name. I want to see a list of albums that have a the in their name. Well, let's just look at the table first before we actually write our filtering commands. A list of albums that have a the in their name. Let's just list them out ourselves before we learn how to filter on this. Album, Summer Mix, Freaked Out and Small, Greatest Hits. Okay, Follow the Reaper, we know, is an album on here that has a the in the name. Follow the Reaper. And I'm going to make a note here. The is lowercase, and it's in the middle of the word. It's in the middle of the album. Let's look at another one. Follow the Reaper, The Carter. Well, that's not the, it's THA, so that one won't work. What about Blueprint 3? That's another one. The Blueprint 3. What is that? That is, it's actually a mixed case. It's written in uppercase at the beginning. And it's at the beginning of the word. Anything else? The Graduate Soundtrack. Ooh, that's the other one. So it looks like there's 3 albums here. Mixed. It's also at the beginning of the word. So we've got quite a conundrum. We want to search for the word the, but there's 2 issues at play. One, the case of the word the is written in uppercase, lowercase, mixed case. It's all over the place. It's written in many different ways. And then secondly, the placement of the could be at the beginning of the word, the middle of the word, or the end of the word. If a new album is added, let's say, for example. So first we need to learn, how do we actually make everything the same case? So we're going to learn actually, we're not going to learn that function first. Let's actually jump into the where clause first before we learn the lower function. I think that would be more helpful. So let's just first learn about pattern matching. We want to search for a string of values in a text column, but it could be written in many different ways. An example of this could be like Mike, Michael, Mikey. Then you would use pattern matching. Or let's say you want to look for people with a name that have the word Ann in their name, like Annabella or Andy or Ann. That's when you would use pattern matching. Or let's say Walmart is written in 5 different ways in your customer database. Walmart lowercase, uppercase, mixed case, Walmart with an apostrophe, a dash, Walmart without a dash. That's where we use pattern matching. So we're going to learn the like command. We're going to say we're album like. And let's just start with album like. Since album is a text column, it gets wrapped in single quotes. Let's just do album like %sign and see what that pulls up. Album like %sign shows us every single album in the table. What does %sign mean when using like? It means any value. It's called a wildcard. So if we search for %sign, that means we're saying, show me an album that just has any value in it. Could be a text, could be a number, could be anything. So now we know what a wildcard does. Let's try using it in conjunction with another character. Let's say we're album like, I don't know, %sign S. Little lowercase s. We're album like %sign lowercase s. What do all of these albums have in common? The album ends in the letter lowercase s specifically. Some Nights, Greatest Hits, Happy Thoughts. It ends in lowercase s. Well, what happens if I say we're album like S, uppercase S, and then %sign? What is that going to do? What do all these albums have in common? Album starts in the letter uppercase S. I hope you're catching on here. This %sign means any value. So S and then any value. Oops. S and then any value. Or up here where it ends, it's like any value and then S. So how can we use what we've learned here to search for the? Let's say we're album like %sign the %sign the. So any value can come before the and any value can come after the, but look for THE. We only get one output. Follow the Reaper. Why is that? Well, remember when we actually manually wrote them down? Follow the Reaper, it's the only one where the is written in lowercase, but in these it's written in uppercase too. Ooh. So that creates a problem for us. So we've solved the placement of the with the %sign, but we haven't solved the case sensitivity issue. So how are we going to do that? I want to introduce you folks to a new function called lower, which says take a column, for example, album, and call it lowercase album. There's also another function called upper, which we'll call upper album, and introduce that as uppercase album. Let's see what these do. Well, here's the album name. Lowercase album makes everything lowercase in the column, and uppercase album makes everything uppercase in that column. We've created these two columns using as alias. Okay, well, that's really powerful. Isn't the now written the same way in every album here? The Blueprint 3, the Follow the Reaper, they're all in lowercase. Okay, so let's use we're lowercase album like the percentage sign the. Lowercase album doesn't exist. What do you mean it doesn't exist? I created it. It's in the select statement. Lowercase album. There it is. It's because the way that SQL is written does not match the order in which it's executed. And what order is SQL executed? Well, first, from looks at the table, then where filters the rows that we're concerned about, and then we select the columns that we want to see. So the lowercase album column hasn't been created yet because of order of operations of SQL. We can't use the alias in the where clause. No aliases in the where clause. I'm going to write it again. No aliases in the where clause. You just can't do it. What goes in there instead? It's the whole function itself, lower album. So instead of saying lowercase album, put the whole function right there in the where clause. Functions can go in the where clause. That's okay. There we go. That gives us the answer that we want to see. So that is how wildcard commands work in SQL. And there is a nuance here because couldn't you have a album that starts with then or the or ends in, or maybe it's the word theme. So you might have to play around with these percentage signs a bit if you're encountering words that include THE. So you might have to get creative. But that's your exposure to pattern matching using the wildcard function. You can see how powerful this could be. It's really cool. I really like it. All right, there's a workshop on filters below that you can work on. Folks, post your answers in the comments for these questions. I think it would really help people. But I actually want to cover aggregates here really quickly at the end. So let's go to the your student SQL Immersive guide. And we're just going to scroll down. And I want to cover what aggregates do before we actually write them in. Aggregates summarize columns of data. And in our example here, just going to zoom in. Maybe it'll be a little easier to see. I'll zoom out a bit. All right, here we go. We just have a very simple table, aggregates. So what are aggregates? They're used to summarize columns of data, typically numeric integer data types. We can also summarize string columns too. They can be placed in the select and having clauses. They'll never go in the group by or where clause. Talk more about that in our next class when we're talking about the group by and then filtering data after we group. But let's look at just a simple table. We got a list of order IDs and then amounts. And hell, what I'm going to do is we're just going to incrementally walk through each aggregate function and we're just going to see what they do to each column of data. So let's start with the sum function. If we sum the amount column, what happens? Well, we're going to sum all the values in the amount column. And what number would pop out? 10 plus 10 plus 5 plus 0 plus null is 25. 25 is what would pop out. What if you sum the order ID column? 5 plus 4 plus 3 plus 2 plus 1. I believe that is 9. Gosh, I'm bad at math. Is that 15? 3 plus 3 is 6. Yes, 15. What do you think is more meaningful, summing the amount column or summing the order ID column? I'm going to say summing the amount column. Meaningful. That's meaningful to me. If you're summing the order ID column, you're just summing up a bunch of social security numbers. You may as well be. It doesn't have much meaning to it. Okay, what about min amount? What if you take the minimum of the amount column? Well, min amount is going to be 0, and the min order ID is going to be 1. Here's what's interesting. Minimum returns the minimum value in a column. It ignores null values. The sum function also ignores null values. So aggregate functions, they don't care about nulls. They don't even consider them. They don't even look at them. Max amount. Well, that's going to be 10. If max sees more than one value that's 10, it's still going to return 10. Only once. What about max order ID? Well, that's going to be the number 5 as well. Also ignores nulls, the max function too. Count. Count amount. What does count do? It returns the count of records in a column and it ignores nulls. So it counts the number of records in a column that aren't null. 1, 2, 3, 4. Ooh, we don't count that. There's only 4 amount records that aren't null. What about the order ID column? There's 1, 2, 3, 4, 5. There's no nulls in there. What do you think is more meaningful, counting amount or counting order ID? I think counting order ID is more meaningful because we count order ID, that tells us the total orders in the table. What's cool with the count function is if you counting the order ID column is going to give you just the total amount of orders in the table. And the order ID is the primary key in this case, which is super interesting. Count distinct. Now, what in the Sam Ellington does count distinct do? Let's read the definition. It returns a unique count of records in a column and it ignores nulls. Count distinct. Okay, so it returns the unique amount of records in a column. It ignores nulls. You know what I think might be helpful? Let's just let's hop over to Excel for a moment. And I'm just going to put this function in here. And in fact, I'm going to take this whole data table and I'm going to pop that into Excel too, just so we can incrementally walk through what in the Sam Ellington count distinct amount's going to do. What do we know about SQL? SQL runs from the inside out. So if we're running distinct first, since it's in the innermost parentheses, distinct is going to do what? Distinct removes duplicates. So 1, distinct runs on amount column. Okay. Here's all the values in the amount column. Bada bing, bada boom. What does distinct do? It removes duplicates. So I'm going to write that note. Removes duplicates. Okay, there's 10. That's a duplicate. Okay, all these other guys are good. 0, 5, 10, and null. We remove the duplicates. What's step 2? We're going to count the records now that aren't null. In the amount column, now that we removed the duplicates, how many records aren't null? 1, 2, 3. Boom. Distinct removes the duplicates. Count counts the records that aren't null. We're leaving us 3. Count distinct counts the unique number of values in a column that aren't null. It's doing 2 things at the same time. So what does count distinct amount return? 3. What do you think count distinct order ID returns? Well, there's no duplicates. Nothing's null. It's 5. Fun fact here. If you want to find out the primary key of a table, count distinct of a column, if that equals the same as the count of some column, that's the primary key. because that means the values don't repeat themselves and they're never null. So count distinct order ID is 5 and count order ID is 5. They're the same number. That tells us that's the primary key. That's a really good hack if you're curious. So now we know what these functions do. You know that distinct doesn't ignore the nulls. It's actually the count part. And I'm going to refer to that often. I'm going to bring that up a lot in this class because I think it's really important. So let's go back to Mode Analytics and do some of these aggregate questions, and then we'll end our class for today. Next class will be the group by and joins. So what's the sum of total plays in the MValary 12 albums table? What do we know about every SQL query? We need select and from. We're going to talk to mvalary12.albums. And then what are we going to do? We're going to sum the plays column. Great. And then let's run it. And actually, I'm going to alias this. I'm going to call it total plays. So we're just learning how to run aggregates right now. Just learning how to run aggregates. 975. What is the count of artists in the MValary 12 albums table? Okay. What does every SQL query need? Select from mvalary12.albums. I want to count the artists in this table as total artists. It says there's 14 artists in the table. What do you folks think? I don't know. What do we know about this table? The granularity of the albums table is that every row represents an album. So if every row represents an album, is it possible that an artist name could repeat itself in this table? We know that that's true. We know an artist name can repeat itself. We saw that in last class, Red Hot Chili Peppers. They got more than one album. What does the count function do? It counts the number of records in a column that aren't null. So it's counting duplicate values. It's counting duplicate values here in the artist column. So there really isn't 14 artists in this table. Actually, if you're counting artists, that's just the total number of albums with an artist name. If you just count the artist column. That's just the total number of albums with an artist. Because what does count do? It ignores nulls. What if we want the unique number of artists in this table? I'm going to do a comma. I'm going to make a new aggregate column in my select statement. Count distinct artists. Distinct removes the duplicates, and then count ignores the nulls. That will give us the total artists, the true total artist number. There is a nuance between count artists and count distinct. There's really 12. I'll make a little note for you folks here. If you aren't counting the primary key column, you need to use count distinct because you're going to get duplicates. When in doubt, if you're choosing between count and count distinct, use count distinct. When in doubt, use count distinct. If you're like, I don't know whether to use count or count distinct, you're going to use count distinct instead. It's a safety net. It'll get rid of the duplicates. When I was working at Amazon, my manager said, hey, I need you to count the total number of Kindle customers that we have worldwide. So what did I do? I went to the orders table and I just said count customer ID. I said there's 20 million Kindle customers. He said, I don't think so, man. 20 million Kindle customers? Sounds like we have 20 million orders. I don't think 20 million Kindle customers. It's because a customer could have more than one order, so I was double counting the customer. I should have been doing count distinct customer ID. Because if I'm looking at an orders table, the primary key is order ID, not customer ID. Takeaway here is this. You could get really bad results if you do not remove the duplicates. You get a really wrong answer. So just be aware, count distinct is important. What's the average number of plays per album? Select average Actually, in SQL, it's just called AVG. Average plays from Envalary 12 albums. Nice, 605. What's the total count of rock albums? Okay, so what do we know about SQL? Well, we need select. I was getting sloppy up there, folks. I'm sorry. I wrote it all in one line. I don't really like doing that. What's the total count of rock albums? Well, what do I want to do? I want to see a count of albums. So I'm going to count album as total albums. But I only want to look at the rock ones. So what do I need? The where clause. Ooh, we're using an aggregate and a filter at the same time. I only want to look at the records that are rock. So I'm going to say where the genre equals rock and then count them. And I can count album here without count distinct because album is unique. It's a primary key. There's 5. What's the total count of pop and rock albums? What do we know about SQL? Select. And from, we're talking to Envalary 12.albums, bada bing, bada boom, where, ooh, this question's cool. We've got multiple criteria in the same column. What does that mean? Where genre in rock, comma, rap. Genre is a text column and needs to be wrapped in single quotes because we're working with text. Genre in rock or rap. That's what that comma really means, is an or. Multiple criteria in the same column. So I'm going to count album as total albums. And then that will give me the total number of rock and rap albums. 8. Okay, folks, what is next? What I recommend you do? Hop into the SQL Immersive homework. Do class 2, where in aggregates. It's a lot of questions about being a bartender at a bar and you're getting asked for different kinds of drinks. And then at the bottom, the aggregate questions are focused on North Korean military missile tests. You might find some of those results alarming, but I think it's just good knowledge just to see how common those practices were at different points in time. The answers are going to be in the answer key. So what's up for next class? Group by and joins homework, or group by and joins the class. Thanks for joining us, and looking forward to seeing you next time. Thank you.